today's lesson, we are talking about addition properties, and we've actually done a lesson like this before, where we've talked about multiplication properties. You've done this in 4th grade as well. So this lesson's kind of like, it's going to be kind of like a review for you. So we're going to talk, because we're talking about addition with decimals on this, in this chapter, we're going to stop to talk about the properties of addition. Basically, the properties are rules that help you figure out how to solve a problem or what order to solve a problem in. So let me show you what I mean. We have to skip the problem of the day today because I know you love it, but we have to skip it because we're minimum day and we're running short on some time. So in your notes, we actually have a little bit we need to write today for our notes. So chapter 5, lesson 7, and you're writing addition properties. The first thing, basically all of these properties are going to help you in adding up problems and hopefully solving some of them in your head without having to do all the math. So it's kind of like a mental math lesson. As I told you before, you've learned about these properties before. This is like a review. So the associative property is the first one. Sorry, it's doing it again. Let's try again. So the associative property is the first one.
Just don't touch the button.
So I'm going to write what the definition of the associative property is, and then we're going to write an example of what it would look like. So first, it's the grouping of numbers, and it doesn't change the sum. So the sum is the answer to your addition problem. And so what we're saying here is the way that you group the numbers when you're adding doesn't change the value. So if I choose to group a couple of numbers differently in order to be able to add them in my head, that's what you should do. So for example, usually you'll see parentheses on these ones. Notice that the numbers are 5, 9, 2 in that order, right? So I'm adding 5 plus 9 plus 2. So what this is saying with this equal sign here, that means that either way you decide to group the numbers, you would still get the same answer. So because you're adding, it doesn't matter what order you add numbers in. And we know that that's called the commutative property, which is a different one that we'll talk about here in a second. Now, the difference between the associative property and the commutative property, the associative property, I'm just grouping numbers that are already next to each other. So the 5 and the 9 are already next to each other, so I could group those together. And the other problem, the 9 and the 2 are next to each other, so they've chosen to group those together and add those first. The commutative property is the next one, and it's a little different because you're actually changing the order of the numbers. So you're shifting the numbers around and moving them, still doesn't change the sum. Okay? So whenever you see parentheses in there, know that you're probably going to be talking about the associative property, more than likely. Because the associative property is how you group the numbers. So whenever you're doing a math problem, you're always going to do whatever's in the parentheses first. So I would add, in this case, the 5 and the 9 first and get 14, and then I'd add 2 to it and I would get 16. Over here I would add the 9 and the 2 first, which gives me 11, and then I add the 5 to it, which gives me 16. So do you see how those are equal to each other? That's what the equal sign in the middle represents. Okay, everybody write that down. We have a couple more things. I kind of already talked about the commutative property, and that's the next one. The commutative property is something that we use for addition and for multiplication. So addition and multiplication, you can actually do the math problem in whatever order you want, as long as we're talking about all adding or all multiplying. Okay, so here's what as long as you don't what?
As long as you don't move the product around, like if you switch if you use the commutative property and you accidentally switch the product with, say, one of the digits.
Well, these ones are all,
would be,
yeah, these ones are all addition though, so this is different. So this means that the order of the numbers do not change the sum. So write that definition and then I'll show you my example. For some reason, my device is being harder for me to write on, so the letters aren't properly forming. So hopefully you can read that. The order of the numbers doesn't, anything that has a curved line in it is not wanting to do that for some reason. The order of the numbers doesn't change the sum. So 5 plus 7 is the same as 7 plus 5. You know that, right?
Yeah.
Same thing goes for multiplication. So 5 times 7 is the same as 7 times 5. So you can mix the numbers up. And even if you have more than two numbers, you can mix them up. So for example, if we have 21 plus 36 plus 17 would be the same as if I mixed them all up. Same thing. Do you see the difference between this one and the associative property? This one has no parentheses, and this one I actually moved all the numbers around. Then it's just then you're looking at the commutative property. You just have to know what the difference is between the two properties. So associative means the numbers are in the same order. You don't move them around. You just add different numbers together first. The commutative property means you might just mix them all up. Like sometimes you do that so that you can add them more easily in your head. So I'll give you another example as soon as I write this down. So this is 74. And this side is also 74. So if you went through and added them all together, you get the same answer on both sides. And then I'm going to show you why the commutative property is one you might want to use, especially when you're trying to add some numbers together in your head. Yes, Nolan?
What if, anyway, so, what if, like, on the associative property,
Yes.
I said that in a long time. Isn't it like where you add numbers before you even do the problem? So it's like.
Well, you're always going to do whatever's in the parentheses first. Is that what you mean? So whatever's in the parentheses, you do first. It is. It's. This is leading us into order of operations. Yeah. So.
Is that,
Yes. It is coming up, but not quite yet. So here's an example. This is kind of what I was saying. If you have numbers like, let's say like this. Numbers like this. What if I have numbers like this? If I were trying to do this addition in my head, wouldn't it be easier to add up this number and this number together first? Because that makes 20. Are you following me? So this is where the commutative property comes in, because I could instead add it up like this, 18 plus 2 and get 20, and then add 11 and I would get 31.
Oh, I see what you did. Okay.
See what I'm doing?
You can do
So
2 plus 11.
you could do 2 plus 11 and you get 13, but then you'd have to add 18 plus 13, which for some people is a little harder. See how I blended two things together that I knew would make a good even number like 20? Same thing like for 10, like maybe you're going to add two things together to get 10. Then add in the third thing. So that's why commutative property is something that you'll want to use when you're doing some mental math, like doing some addition in your head.
Couldn't you, is there any way to combine the associative and the commutative?
Well, associative is different because you keep the same order. See how I mixed up the order here?
What if you
So
use the commutative?
are you saying to
and then
put
the
parentheses like this? So you could technically, first I use the commutative property, second I use the associative property, technically.
What would that be called?
It would be called just what I said. You'd first use commutative and then associative. So technically I did use both because I first reordered them and then I put a parentheses around. Or I decided which ones I wanted to add up first. Yes? Not yet. Not yet. Just, you have some left in there. Okay, last one is called the identity property. Now this one means that any number plus 0 equals the number that you started with. Now, the reason why we're doing this in a decimal chapter is to let you know that these same properties hold true with decimals also. As long as you're adding them, you're going to still be doing the same thing. So for my example here would be 46 and 8/10 plus 0 is just going to give me 46 and 8/10. So we know that these properties, you learned about these properties in 4th grade, but now we're talking about them again in 5th grade because we wanted to let you know that it still works for decimals. So if I'm trying to add decimals in my head, I might add up some that I know are going to equal a whole, like 4/10 and 6/10. Think about it for a second. 4/10 looks like this, plus 6/10. I know that equals a whole, right? So maybe if I have some numbers like that, I could easily do this math question in my head, couldn't I, using a couple of those properties, knowing that 4/10 and 6/10 equals 1, and anything added to 0 just equals what you had, which would just equal 1. So you can mix them up and try to figure out what's the best property to use for these. Yes, sir.
I know I'm putting Prodigy into reference right now. But anyway, on Prodigy, I've been having to multiply decimals.
Oh,
like
okay.
0 point something. I found out a trick.
Well, hold on. Don't tell us about multiplying decimals. I don't want to go there yet because we have a short amount of time left. I want to make sure we get this. And I don't want to confuse anyone. We will be multiplying decimals in the next chapter. So if you've already gotten there, then it's because you've already passed all the stuff that I've assigned to you. So then they put you at a level that they think you're at. That's why. All right. So let's move on. Let's look at your example page. I want you to look at your example page. Example number 1. Let's look at the examples first before you start the assignment. Example number 1 says Elijah recorded the number of different movies that he watched last month. Use properties of addition to mentally find the total number of movies. So as I told you when we were doing notes, we're talking about trying to do things mentally. So you're trying to order these numbers or move these numbers around in such a way that you could do the math in your head. Okay? What happens if you really can't do the math in your head? Could you just add them up? Yes. What I'm trying to show you today is some easier ways to be able to do them in your head. But you could just add them up if you wanted to just add them up. But for some of you, figuring out these tricks are going to save you some time. So we have 5 comedy movies, 27 action movies, and 15 dramas. So it says that you need to find 5 plus 27 plus 15. You can easily add 5 and 15. So if you change the order and you group those numbers together. Everybody listening to that? So you would change the order. Just like that last example I showed you. Being able to say, I know that 5 and 15 equals 20. And because that's a number that ends in 0, it's easy to add. So I'm going to change the order. So over here, this is the original order. Now we're going to make it 27 plus 5 plus 15. And do you see how then they put the parentheses around the 5 and the 15? So far we've used the commutative property right here because we reordered the numbers. Then we use the associative property right here because we put a parenthesis around and grouped a certain set of numbers. Everybody see that? Now we can do our addition. So we're going to add what's in the parentheses first, which is 5 and 15. That gives us 20. And then we can add 20 plus 27. Anybody know what that is in their head? Ashley, what do you think?
47.
47. So we were able to add all of those 3 numbers together in our heads without using all the work, just by using 2 properties. We used commutative by switching the order of the numbers so that it made more sense to add up in your head. Do you think that's going to work every single problem?
No.
Right, I'm glad you said that. So it's not going to work every single time. Sometimes you're going to get 3 or 4 numbers, and none of them, when you add them together, are going to equal something nice like 10 or 20. Sometimes it will, though, and if it does, that's the time when you should use that property. Okay? Let's look at example number 2. This one says to use the properties to find 1 and 8/10 plus 2 and 6/10 plus 0 mentally. So now they're trying to they're trying to show you how you might add these things together. So they kind of pulled the whole numbers out. See how all of a sudden it got harder? Because now we're looking at decimals. So in these parentheses here, notice that what they're doing is they're saying 1 and 8/10, sorry. The 1 would be part and the 8th would be a part. Then you have 2 and 6/10. So we have the 2 plus the 6/10. Because if you add up the whole numbers first, just pay attention to the screen. The whole numbers first, and then you add up the rest, you could do it in your head and not have to write it all out. We already know that anything added with 0 is going to give you whatever you have. So that's this identity property way down here. So whatever we get, we don't have to worry about the 0. So 1 plus 2, I'm going to reorder. I'm reordering some things here. And then 8/10 plus 6/10. So I'm going to first add up my whole numbers. So there's my associative property coming into play, because I'm now regrouping my, hold on. I'm now regrouping it. So I'm going to rewrite it. 1 plus 2, I'm going to do my whole numbers first, and then I'm going to add up my decimals. So I'm using commutative property because I mixed up the order. Well, I actually decomposed the numbers, right? I pulled out the whole number and I left the decimal part, and then I'm going to add up the whole numbers first. So 1 and 2 is 3, right? So I know that my whole numbers are going to be 3. Anybody know what 8/10 and 6/10 would equal? Think about what that would look like. Amelia, what do you think? 1 and 4/10, right? Because 8/10 plus 2 more gives you a whole, and then you'd have 4 left. So 1 and 4/10. Also 8 and 6 is 14, isn't it? And you put the decimal in the middle, so you can think of it like that too. So now I can add up, now I have 3 wholes and 1 whole, which is 4, and 4/10. Everybody see where I got that?
Yeah.
So, because I took the 2 wholes and then I left the decimal alone. Yeah. Now I have the identity property, meaning I'm adding 0 to it, which just leaves it as 4 and 4/10.
Why would you want to put 0 on the end of it?
Well, that was part of the question. Look. See? That was part of the question.
Well, yeah, but why?
I would have probably done identity property first and knocked the 0 out. Is that what you mean?
Yeah.
Okay, so if you see a 0...
Why did you put a 0 that's not needed? That wouldn't do anything.
Well, let's say that this person's using some data. So they have 3 pieces of data, and so they want to include all the data, even if one of them is a 0. I see what you're saying, that why would you even leave it till the end? And I would think the same as you. At the beginning, I would probably use the identity property at the beginning, saying I'm just going to kind of get rid of the 0 because I'm adding, and I know it's not going to change the value of my answer. So I would have forgotten about it from the beginning too. And then I would do commutative and associative. On this problem, they wanted you to see how you've used all 3 properties in one problem. Do you see why decomposing the number and taking out the whole numbers and then adding those separately helps you to be able to do it in your head? Let's do a couple of examples, a couple of your problems here together.
No.
I always do it on this lesson because people tend to understand how to do the adding and stuff. What they don't understand is which property are they using. That's where you write which property you're using. So Amelia is showing us on the independent practice page. You've got a whole bunch of lines on the side, meaning what kind of properties are you using. So I'm going to switch ahead to that. Looks like this. So look at number 2. Let's do number 2 together. Let's skip the guided practice for a second and go to number 2. Because these ones are the ones that are so different. Oh, sorry. Just watch. Since you're back from band. All right, so they've actually done all the work for you on these 2 questions, and you have to decide what kinds of properties have they used. So your choices are one of 3 things: commutative, associative, identity. You could use more than one in the problem, or sometimes you only use one, sometimes you use two. It just depends. So the first question is 69 plus 22. Then they decomposed the 69 and made it 60 plus 9. Decomposed the 22 and made it 22, 20, and 2. Then they reordered the numbers. What is it? What did I do when I reordered the numbers? Because look at, right here there is no line. Right here is where they, right here is where they did something. This is where the line is. That's where they reordered the numbers. So Nolan, what would that be called?
That would be commutative.
Commutative.
Is there a property that is called when you split them up?
No, that's just no. There's not a property. It's just a part of what we're doing to help mentally add it. Then I grouped the numbers together using parentheses. So what property did I use right there? Which one? The associative. Sorry about that. Something needs to happen here because it's not.
What is this if I add?
And then all they did was add and then add.
Wait, how did I erase?
Because the lines started again, so I had to erase it. So now all they did is they already gave you the steps over here. Then they added, and then they added again. Number 3, I had all these numbers here. 11 plus 7 and 7/10 plus 4 and 3/10 plus 0. And what they're saying is, did they change the order here?
No.
Look at the next number. Look on the other side of this equal sign. Did they change the order? Between here and here, are the numbers in the same order? Are the numbers in the same order? Yes, thank you for the thumbs up. So because the numbers are in the same order, and they chose to add these together first, what property did we use? Hamza? No, not identity on that one. Not yet. There is a 0 in there, but associative. So because the numbers were not moved around. See up here at the top? The numbers were moved around. We took the 60 and the 9 and we split them up and put them in different orders to add them more easily. So that's the difference between commutative and associative. When you don't change the order, it's just called associative. When you move them all around to add them up, that's called commutative. Then we add, and this one has a 0 in it. So if you see a 0 in the number or in the problem, then you know that, what is it called, Malachi? Identity. So anytime you see a 0 in the problem, you know that at some point in that problem you will use the identity property. All right? So fill those in, and we'll even do a couple more because we have a little bit more time. I want to make sure you're getting this before we stop. I'm going to stop this first. Oh.